Good morning. Today we are talking about lesson 612 and 613. Really, we're going to keep talking about what we talked about in the previous lesson and just add a little bit into flowcharts. Identify shortcuts and apply them to shortcuts. And apply them to flowcharts. So this is just a brief review of what we came up with yesterday. And what it's telling us is if I have two sets of triangles that have one of these conditions, okay? So if I'm looking at this one, if I have two sets of triangles that each have two angles shown congruent and one side length showed congruent, not in between the two angles. So remember, AAS, oh man, quick drawing, angle, and angle, two angles in the same triangle, and a side that is not in between them. Okay, so let's say this side. If I have AAS shown to be exactly the same in two triangles, that is enough to say that these triangles are congruent by angle, side congruence. Okay, that's what these are saying. Anything with a check mark is enough information to show that it is, that the two triangles are congruent. These two are the ones that are not enough to show. If it's AAA, two different triangles that have three angles that are the same in both triangles, not enough to show that the triangles are congruent. They're similar, just not necessarily congruent, okay? Same with ASS, okay, or SSA. If you know two side lengths in two triangles are the same, and an angle that is not in between them, not the one that's joining them, a different one, that is not enough to show that two triangles are congruent, okay? HL, remember, stands for hypotenuse leg. Hypotenuse. And that can only happen in right triangles. That's a special case of ASS. All right, so what we're being asked to do is just to decide in each group of triangles, are the triangles congruent, yes or no? And we're gonna just I should just leave this right here, keep referring back to this list, because if it has this information with the checks, then it's a yes. If it doesn't, it's a no. So here, I see, again, you guys know me and my colors. So the 70 are the same, okay? Then I have 11 and 11 that are the same, and I also have 8 and 8 that are the same. So two sides that are the same and the angle that joins them. That's SAS, that's a yes. So I'm gonna write down, are the triangles congruent? Yeah, I'm just gonna put SAS congruence, okay? Part B, over here, okay? I've got 31 and 31, those are exactly the same. I've got 42 and 42, exactly the same. And I've got 40 and 40, so all three sides are exactly the same. So those triangles are congruent by SSS. Okay, three sides in one triangle, three sides in another, that's where SSS comes from. Okay. Part C. Okay, part C. I've got 12, that's the same. I have 16, that's the same. Now I have to be really, really careful here because I do see two angles that are the same. However, in this triangle, the angle is included or in between. So this would be showing me SS with the angle in between, SAS, for this triangle. For this other triangle over here, notice this angle, although it's marked the same, it is not the one that is connecting the two. Okay, it does not connect these two sides that are marked. So this one is actually ASS, okay? Because it's two sides, but the A is not matching. The A is not connecting the two. It's not in between. So anytime these two things don't match, the automatic answer is not congruent or maybe not enough information to determine if they're congruent, okay? So C is a big no. A and B were both yeses. They both had the same information in the same order. All right, part D is a pretty good one. In part D, we have to remember some things, okay? the first thing that we need to remember in part D is that when we have, well, let's do the easy one first. We've got 6 and 6. Easy. Let's make it easy. Okay, let the easy stuff be easy. Now, when we have two triangles touching like that, or two kissing fish, remember these are vertical angles. Those vertical angles must be congruent. The other thing we know is we have two parallel lines here. I know that because of the arrows. And so when I see those two parallel lines, that tells me that alternate interior angles are congruent. So I could either mark these two or the other two, okay? And if you marked the other two, you'd have a little bit different answer than what I'm gonna show you here. If you mark the two that I did, okay, notice it's two angles and a side. In each triangle, two angles and a side, but it's not the side that's connecting the two angles. So two angles and a side. Let me check my list. AAS, two angles and a side not connecting, that's a yes, okay? Now, if you had instead marked, so this is if you marked yellow. If instead you had marked these alternate interior angles, which would be completely correct, you might say angle, angle with the side connecting, which is ASA. So these triangles actually have two different ways to prove them congruent, and you could have picked either one. You do not have to write both, okay? But I did want to show either answer is correct. Okay, we've got 4 more examples here. Still part of 6-13, okay? And these get a little bit trickier. Part E. All right, I have two angles that are marked the same. And remember, we have this thing called the reflexive property. So this side length is exactly the same in both. And when it's the same exact length in both triangles, I put an X on it, and we call that the reflexive property. Remember, it's kind of like a reflection in the mirror when you look at yourself. What you see back is the same thing. If you're the same segment in two triangles, or maybe the same angle in two triangles, we call that congruent by the reflexive property. It is congruent to itself, okay? Then I have these parallel lines again. Now this one I have to be a little bit careful because all 3 of these, they are transversals, but only one really connects the two triangles together. For example, this is a transversal between the two parallel lines, but it really is only a part of the top triangle. This one is really, it touches the top triangle. This one's really only a part of the bottom triangle. So I'm going to use this orange transversal, and I'm going to mark alternate interior angles. Okay? Now again, I have two angles in each triangle, green and blue. Two angles in each triangle that are the same as each other, and one side, okay? Two angles and one side. But again, that side does not connect in one triangle. The orange side does not connect the two angles that we know, okay? So angle, angle, side, congruence. This one is not one I could prove two different ways. It is just angle, angle, side. All right, letter F. Again, I see that reflexive property right down the middle. This side length is shared between the left side and the right side by that reflexive property, okay? I also see these two, congruent, congruent, and I see these parts, congruent, congruent. So all 3 sides in one triangle are congruent to all 3 sides in another, so I can say that they are congruent by SSS. Okay? All right. Oh man, gee, that looks kind of funny. I got to be careful with this one. So I have these angles that are the same. I have these angles that are the same. And I have these angles the same. That's what I see. The angles are all the same. I don't see any sides that are the same. These are touching, but this obviously is not the whole side length for the top triangle. It's just the whole side length for the bottom triangle. So I have no information at all about sides. So I would call this AAA or AAA. But remember, AAA does not prove that triangles are congruent. It proves that they're similar. These two triangles are definitely similar by angle similarity, but they are not congruent. And that was the original question. Okay, finally, part H. Okay, I see that reflexive property again. We've got to get so good at paying attention and seeing this side length, the whole length, is the same in both the top and the bottom triangles, exactly the same. So it's definitely congruent to itself, okay? Then I have angles that are congruent and another set of sides. Okay, so in each triangle, remember not total, but in each triangle I have two sides and an angle, okay? Two sides at an angle, two sides at an angle. Ooh, so this is tricky. When I have two sides at an angle, I really have to pay attention to which one it is because SAS makes them congruent, but ASS does not. Because this angle is not literally in between the two marked sides, it's not in between, it makes it the ASS, which we know not congruent. Okay? In addition to that, what we want to be able to do is take one of these that we said yes to, okay? One that we said yes to, E, F, D, A, or B, and we want to be able to create a flow chart because I know flow charts are your favorite. I am going to pick D. And remember, D we had a couple different correct answers for, okay? And on my paper, I'm going to do my best to draw this out. And I'm going to give it letters because there's no letters here. A, B, C, D, E. 6 and 6 were given. Parallel lines were given. Okay, that was all that was given. So as I make my flow chart, I'm going to make my flow chart in purple. So it's a little different from that just so we can see anything I add in. You're going to see it in my colors anyway. Okay, let's start with the easy stuff. Okay, the easy stuff is that. Now this is a little different in congruent triangles than it was for similarity. I'm not going to give a ratio. I'm going to say BC is equal to CE. Those two side lengths, actually I probably should give me segments and say congruent. If you put that the two segments are equal, it's okay. But probably the best way to say it is BC and CE is congruent. And I can write given. If the numbers are the same, I can write given down, okay? Then I'm going to move on to what we talked about earlier with the vertical angles, okay? Now remember, with vertical angles, when they touch in the middle, I either have to number the angles like 1 and 2, or I have to use 3 letters, okay? I'm going to go kind of the lazy route and mark them 1 and 2. And I'm going to say angle 1 is congruent to angle 2. Now that was not given. That was not part of the original problem. I had to mark that myself. But my reason is vertical angles are congruent, okay? 100% of the time, vertical angles, I'm gonna sneak this under here so I have more space and you can see, okay? 100% of the time, vertical angles are congruent. So I have side and I have angle. Now remember, I have to pick, and I'm gonna do the sides in purple since that's the bubble color I used. Now I have to pick, because lines are parallel, I have to pick which angles I'm going to use. And honestly, you can pick whichever ones you want, okay? I'm going to go with parallel lines cut by the purple transversal. And I have these two angles are the same. Now, each of those angles only have one letter next to it, so it's not confusing to use B and E, okay? So I'm going to say angle B is congruent to angle E. And the reason is if lines are parallel,